Hello guys, in this video I'm going to explain the working of Kruskal algorithm and I'm also explain the time complexity and application of Kruskal algorithm also. So first we know why we use Kruskal algorithm. So Kruskal Kruskal algorithm is a greedy algorithm used to find minimum spanning tree. Basically we use Kruskal algorithm to find the minimum spanning tree of a connected, weighted and undirected graph. What is connected means like we have three vertices a b c. Now we can say all these three are connected to each other. Weighted, what is weighted means? Weighted means weights are given on the edges like 2, 1, 3. These weights may be anything. They can be the profit, they can be the cost, they can be the distance. It's depend on the question. And undirected basically means there are no direction. Like as you can see in all the edges there are no direction. Now if the direction are given, then it looks like this. It is directed. But when we use Kruskal algorithm, the graph is undirected, weighted and connected. Now what is the goal of the Kruskal algorithm? The goal is to find a subset of the graph's edges. Means we have to find the subset of a graph. Means the output of a Kruskal algorithm is also a graph, but it's a subset because Kruskal algorithm output contain all the vertices of the given graph. Suppose in our given graph G, we have three vertices and three edges. Okay, so in our Kruskal output there are suppose equal number of vertices, but they have edges v minus 1. Means Kruskal algorithm contain the equal number of vertices as given in the graph, but it contain edges v minus 1, means one less than from the total vertices. Now how Kruskal algorithm work? So basically we have 5 steps. Step 1. First, sort all the edges in the graph from the lowest weight to the highest weight. Means first arrange all the edges in increasing order by their weight. Suppose we have edges with weight. We have 3 edges with weight 2, 4, 5. So arrange these edges in the increasing order or known decreasing order. Now come to our next step. Pick the smallest edge. You have to select the edge which have minimum weight. Now you can choose the first one because we already arrange the edges in increasing order or in non-decreasing order. So the first one is the smallest one. Now if check, we have to check before adding the edge to our graph. We have to check, is this create a cycle with the edges already selected. Suppose that we have a graph like A, B, C. Like we have to add this edge, and now this edge have minimum weight from others. So we have add this, but we are not add this because it will create the cycle. So we have to avoid the edge who create the cycle. Okay. Now come to our third point. If no cycle is formed, as we already checked, if the edge not from the cycle, so we can include this edge into our MST. And if a cycle is formed, simply discard the edge. Like in this case we are discarding the edge. Okay. Now come to our last step. Repeat until there are v minus 1 edges. So we have to repeat this step until we have total v minus 1 edges in our MST, where v is the number of vertices. Means we repeat these above steps until we have total v minus 1 edges in our MST. Now I'm going to explain how Kruskal algorithm question is solved. So suppose in the question you have given a graph and you have to find the MST, minimum spanning tree. So basically first arrange all the edges in increasing order by their weight, as you can see in the working steps. So basically our first sort all edges in the graph from the lowest weight to the highest. Okay, so basically start from here. Okay, now arrange all the edges in increasing order by their weight. Okay, so basically our we are given 1, 2, 3 times 3, then 4, 5, 7, 8, 9. Okay, so basically 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now take the minimum one. The one is minimum from this, and before that create the forest of the vertices in which are given in the graph. So design the forest. Basically you have to design as it is. A, only make the vertices, do not connect any node. Okay, F and G. Okay, now in these select the minimum one. Okay, so where in the graph you can see one is present here, C to E. So we, before making the edge from C to E, we have to check is this create any cycle. So it not create any cycle, so we can easily create the edge. Okay, now remaining are these 2, 3, 3, 3, 4, 5, 7, 8, 9. Now select the minimum one. Now minimum is 2. Okay, so where in the graph 2 is present, 2 is A as A to B. So A to B, if we create the edge, it not create any cycle. So we can directly make the edge. Okay, now remaining edges are 5, 7, 8, 9. Now select the minimum one. Now minimum is 3. As you can see, 3, we have 3 edges whose weight are 3. Means we have 3 edges. One is A to C, one is A to D, and another one is B to E. So you can choose anyone as you want. So basically, if I'm choose A to D, because it will not create any cycle. Okay, now choose from now choose the minimum from remaining edges. So it is also 3. If you create this, it will not create any cycle, so you can simply use it. Okay, now choose from remaining edges. The minimum will be 3. So basically when you are going if we join this, basically if we join this, so basically it will create a cycle. So we know we are not add this edge. Basically we discard it because it will create the cycle. Okay, now simply reject it from the here. Now we have these edges. So find the minimum 4. So where 4 is present? 4 is present from here, from B to C. Okay, so if we make the edge from B to C, it will also make the cycle, as you can see the clearly. So we are not going to add this edge into a spanning tree. We are going to discard it. So I'm not add this edge B to C because it will create a cycle. So now select the minimum from the remaining edges. So minimum is 5. Now check where 5 is present. 5 is from C to D. Okay, if we make a edge from C to D, it will also create a cycle. Okay, so we are not going to include this edge. Okay, now find the minimum from remaining. So we have 7. Okay, so 7 is from D to F. When we add this, it will not create any cycle, so we can add it. Now select the minimum from the available edges. So the minimum is 8. Basically where 8 is present, 8 is from E to F. When we add E to F, it will also create a cycle. From this you can see the cycle clearly. So we are also avoid this edge because minimum spanning tree cannot contain the cycle. We have to avoid the cycle. Okay, now come to the last edge, which have fit 9. Okay, so basically where 9 is present, 9 is the edge from F to G. Okay, so basically we are creating the edge from F to G because it will not make any loop. Okay, so this is our final minimum spanning tree. Okay, now you can see we have all the vertices in our given graph. We have 1 2 3 4 5 6 7. Total we have 7 vertices. In our minimum spanning tree we also have 1 2 3 4 5 6 7. Means given graph vertices equal to MST vertices. Okay, and MST have total edges V minus 1 edges. So you can count we have total 1 2 3 4 5 6 7. We have total 7 vertices. Okay, so we must have total edges 7 minus 1 equal to 6 edges in our MST. Okay, so count the total edges in our MST: 1 2 3 4 5 6. Okay, so it is our final minimum spanning tree. We have another algorithm, which is Prim's algorithm, which we use to create the minimum spanning tree. Both give the same output, Prim's and Kruskal, but the difference is that how they actually work. The difference is in their approach. Cost of cost of MST minimum spanning. So cost of spanning minimum spanning tree is equal to the sum of all the edges weight in the minimum spanning tree. So basically we have 2 plus 3 plus 3 plus 1 plus 7 plus 9 equals to 3 6 9 9 or 7 is 16 and 9 25. So the cost of minimum spanning tree is 25. Now come to the time complexity of the minimum spanning tree. So the time complexity of the minimum spanning tree is E log E, where E is edges. Okay, applications where we use the Kruskal algorithm in real world. It is widely used in network design, such as planning cable networks or travel routes, where minimizing the total connection cost is essential. Basically, we use the Kruskal algorithm in network designing, like we have to use the cables in over an city. Okay, so we use Kruskal algorithm to find the minimum cost of the cable we need. to use the cable in whole the city. Okay, I hope this will help you guys. So if you like this video, please like and subscribe my channel.